Hello again. Now we're going to walk through the forest cover change example in the course notes. So starting around here. So I'm gonna run through this and run the code live and talk you through what I'm doing. So the first section is navigating to the Assets tab and uploading the ward shapefile that is part of the zip folder hopefully you've been provided with. I'm not going to do this because mine are already uploaded. But I'll show you where they are in my Assets tab. So if I go to the Assets tab, this is the data that I've uploaded, NPT. This is the ward data. So if you go to your Google Earth Engine IDE interface, so login and everything else, and then create a new asset, select the files you wish to upload. You need to give them an asset ID. You need also to select all the files associated with the shapefile, so the database file, the project file, the shapefile, and the SHX file. This is vector data for the boundaries of wards in Neath Talbot. So this is the work I did for Neath Talbot, summarising forest cover loss in their wards. They were just interested to see the change through time in this data. So next we're going to cut and paste this code here from the course notes into the script editor. This bit of code here uses microshooting NPT will need to be amended by yourselves to whatever the asset ID is here in your assets tab. So whatever you've called it will need to be changed from microshooting NPT here. So it'll need to be your name or your username for Google Earth Engine followed by the name of the asset. So if we put this text, this code in, this line of code here, line 1 is creating a variable called
I don't understand
wards and assigning this an E feature collection located here to the variable wards. So you're telling GE that wards is equal to this. Then we're using the function map center object to center the map down here at the center of the wards vector using a magnification of 11. Then we're adding the layer, which is the wards layer, to the base map, calling it wards, and we're just using the default visible vis parameters which would be included in here. So if I just run that, then that takes us to Neath Talbot, and you should be seeing the ward boundaries appear as this. If we look in the layers drop down here, you can see this is the wards layer that we just uploaded up. So you can click it on and off, and you can also change the transparency, so change to the satellite base map as well if you want. And these are the ward boundaries for the county of Neath Talbot. So next, what we're going to do is upload the global forest change dataset we had a quick play with earlier on into our code editor, and we are going to visualize it. So again, if you copy this script and add it into here. So now we've got this code again, var, creating a variable with these names, GFC, which is uploading this dataset here, the Hansen Global Forest Change dataset for 2018, and then we're creating tree cover, loss, and gain. And from these we're selecting different variables from this image. So we're selecting tree cover in 2000, loss between 2000 and 2018 in the loss image, a gain in the gain image variable. So these are subsidiary data sets within this wider data set, and then we're adding these to the map in the browser below, in green for tree cover, loss in red, these are the hex codes for the colors here, and gain in blue, and we're assigning their names in these character strings, so forest cover, loss, and gain, and these will appear in the layers name tab here. So if you run this, then this is what we get. So this is a visualization of the global forest cover change data set in the integrated development environment. and from an area we looked at earlier on actually. So you can see the areas of loss in red and gain in blue. So we can turn off forest cover and just look at the loss and the gain, or we can look at just the loss. And this is the data we're going to use taking forward now to summarize by ward, give an idea of what's forest change, what's happened over a course of time. So now, the next step, we're going to focus in on East Port Talbot, which is the ward data we just loaded in. And there's a whole length of script here, JavaScript, which we're going to copy out, put into our script editor. I'll just give you a quick walkthrough of this code. So again, we're loading in the ward boundaries. So that again, this will need updating here to your relevant asset details. Continental USA, that's not correct. Probably came from where I pinched some of this code from. But then we're adding this variable table, this object table, adding it as a layer in this color and calling it wards. Then we're loading up the global forest change data set, printing this to the console so we can inspect this. We'll have a look at that in a second. Drawing out the variables we're interested in. And then here in line 19, 20, 21, we're creating new images where we're multiplying the image pixels by their area. So this is assigning the pixel area to each value to each pixel rather than whether it's a loss or a gain or a tree cover, which is just a binary yes no, or zeros and ones. This is because we're interested in actually calculating area rather than just counting the number of pixels. It's due to how we calculate the things in Google Earth Engine. You'll see in a sec. So again, we're adding these layers in green and red and blue, so we'll get to see the same output again. And then how we're calculating our loss and our gain in these wards is in these lines here, 35 or 36, 37, 38, 39, 40, and we're creating a variable called LStats or loss stats. And this is taking the loss area image which we created higher up here, and it's reducing it regions. So this is summarizing by region, so reducing by region, and the reducer we're using is EE reduces sum. So this is just summing the data within these regions, and the regions we want to sum within are provided by the geometry of table. And table, as you recall, is, or maybe don't recall, is the EE feature collection, so the shape file we loaded here for the East Port Talbot boards. So it's basically summing the area within these geometries for the loss area image. The scale it's doing this at is 30, and this is because the pixel resolution within Ansat data is 30 meters. So this is a native scale, so it's in the scale of the image provided, and you want this scale to be equivalent or to the scale of the images as far as possible. And then what we're asking it to do in lines 42 is print this to the console, how much loss in square meters. So this is doing it for the whole geometry of table, rather than summarizing by each ward. So we'll just get a total loss, and then the same for gain stats, and we'll get a total gain in East Port Talbot. So if we run this quickly and go to the console tab, so you can see the images appearing down below, and you can see we've got the total forest loss in East Port Talbot in square meters, and the total forest gain in East Port Talbot in square meters. And we see there's been a net loss over the 2000 to 2018 period. Also, you'll recall that we printed GFC, the Global Forest Change data set, to the console, and print is a great tool to troubleshoot code when you're developing code, as it allows you to inspect objects really easily. So you can see that this is the data set that we've uploaded, and you can have a look at the properties of it. There's some metadata and descriptions about it, and the bands that are available. So you can see tree cover loss gain and the loss year. This is an interesting one. We can use that to identify when loss occurred. So yeah, print is a really useful tool, and when your code is breaking, suggest you start printing out variables and objects to find out what's going wrong where. So that's a application to calculate total forest loss. We can see that there's net loss of 1,982 hectares between 2000 and 2018, and this is probably largely due to coniferous forestry felling due to disease, Phytophthora, which is an infection that's badly hit crops in South East Wales and across the UK actually, and led to a lot of larch felling in these areas. But now I'd like to explore more the spatial distribution of this loss. So if we cut and paste this code into the editor, much of this code is the same as you've previously applied, so I won't go through it all again. Just go through where we start getting different. So as you recall, we summarized the data by table here and summed it for this. What we're going to do now is use these lstat and gstat objects. We're going to print so we can have a look at them, and then we're going to use them to create maps. So we visualize them as a map. We're creating an empty map, and then we're painting these maps, filling them up with the data from lstats with the variable sum. This is how we're going to show them, the hex codes for the colors we want to use. So this is the palette of colors I'm going to use, and I'm adding the layer fill loss to the map with this palette and calling it sum loss. This is the name of the layer that will appear in the layers here, and then doing the same for the gain. So let's run this and see what happens. So yeah, now you can see we've got a map of forest loss and gain for the wards of Neath Talbot between 2000 and 2018. So we can turn these off and on and see is there any difference between the areas of gain and the areas of loss. Yeah, I think the values of the data here are causing most of the data to appear this single color yellow. So this max value here might be worth playing with these values to see what change that might make. I think if we inspect the feature collections here, which are, if you remember, we printed the gstats and printed the lstats of the console. So this is lstats, this is gstats, so loss and gain. So if we have a look at the feature collection, so we've got the columns. So what columns have we got? So the sum, this is what we're using to create our map. So if we have a look at some of these features and look at the properties, we can see the kind of magnitude of the area associated with each of these properties. So, and this max value is the max value associated with the data. So if we play with these, then we'll get probably slightly different visualizations of the data. So I'd encourage you to do that yourself and see how it changes the distribution and the variation in the data displays. So you can see that's changed again, and obviously a good way of having a look at this would be to look at the distribution of that data and bin them appropriately, maybe quantiles or something like that. And then, so the next step, we've looked at the spatial distribution, and perhaps what might be quite interesting to do next is you can export these to assets on your Earth engine if you want, which is the next section up here. I'm not going to run that code with you now, but what we are going to do is visualize this data using an interactive chart. And this is again a really good way of checking your data, but also of communicating results to quickly to yourself and peers. It's not really a tool useful for creating maps for charts for papers. It's really a bit rough and ready, but it can be a really useful communication tool and sense check tool data. So if you just cut and paste this code in to create a chart, so this is created in a variable or an object called plot loss, and it's using this function UI chart feature by feature. So it's creating a user interface chart using a feature object, which is a shapefile, and it's doing it by feature. So it's taking L stats, and it's taking name, variables name and sum, and it's going to create a column chart with the title this, and the horizontal axis this, and the vertical axis this, and then it's going to print it. So if we run it all again, we get our maps back, but we also get a column chart with the names of the wards on the horizontal axis and the forest loss in meters squared on the vertical axis. We can see this distribution of forest loss by ward over this 2000 to 2018 time frame. I'm going to stop this video here before we go on to the